Okay, so we'll be talking about arc flash today. Just before I started the recording, I have played a couple of those videos that are included in the posted lecture notes, so you can click on that and watch them yourself. First was a tree branch falling onto some power lines, and there'll be like 1300 volts going across that, so it created a spark that moved across the two potentials of the power lines. And the other video was this one here. And this is a mannequin, and it is a uncontrolled explosion. Just to give the visuals of what arc flash can do and how effective possibly could be the protective clothing that the mannequin would wear. So if you click on that, you're going to see a slow motion of an arc flash. All right. So let's go here. So arc flash and boundaries. All right, we're going to, so we get a little bit of visual of what arc flash is. Here are a couple of images of arc flash as well. Um, so let's just see some of the definitions here. An arc flash is an explosion caused by the release of energy generated by an electric arc. An arc is a jump of electrons between two potentials, sudden jump of electrons. Sometimes we can use the arc to our advantage. For example, welding. It's a controlled arc flash that heats up the metal and melts it, and all kinds of joining is happening. So welding is wanted arc flash. But what we're going to talk about is the unwanted explosion. So again, arc flash is an explosion caused by the release of energy generated by an electric arc. All right, what can cause the arc flash? The causes of arc flash include dust, water, impurities, contamination, corrosion, and animals. Let's just stop right here for a second. It is extremely important that the electrical equipment is kept clean. Some of the most common places that there is dust accumulation in greater probability than others would be industrial environment, especially when we're talking about, well, woodworking facilities. The sawdust is in the air and it is there constantly, and it just basically sets in all kinds of surfaces, including electrical panels. So there is an ongoing maintenance in woodworking facilities, especially, to periodically just open the panels and blow off the dust. And quite often it's done just once a week, just to make sure that there's no accumulation of the sawdust. And water. So this is a tricky one here, because well, you're not going to pour water on electrical panel on regular basis. That's something just we just don't do. However, when there's dust, there is moisture in the air, and some of the sawdust, for example, sawdust, can accumulate some of the moisture, and that can create quite a bit interesting scenario. Because if there's enough moisture in the air, and if the dust retains enough water, it becomes conductive. Boom, here is your result. All right. Impurities, contaminations, corrosion, and animals. Animals is a big thing as well. Some of the rodents can climb into, can find their way. Sometimes they're not supposed to. However, there's always the possibility that some rodent is going to crawl into some sort of a transformer station or something like that. And of course, the body, human body, animal body, does have certain type of resistance that is lower than the air, and it can become conductive. And if there's enough energy, you just saw on the pictures on the video what can happen. All right, so that would be the one of the causes for arc flash. Discharge from accidental contact, dropped or improper tools. Whenever there are some works being done on high voltage or high energy equipment, there are specific procedures, and that varies from one company to another, to make sure that the risk of a tool falling out of your hand or making contact with the electrical equipment otherwise is minimized or eliminated, because tools can be conductive, and if they fall onto the electrical equipment, they can cause an arc flash, right? Over voltage across narrow gaps. Well, uh, when you were doing your labs on your breadboards, so you are using 5 volts, 10 volts, 12 volts on your breadboards. So if you have the two terminals and they're close to each other, a 5 volts is not going to cause an arc flash. However, if you have thousands of volts, then the air comes into play, because air does have certain resistance, which means it is not infinite resistance. Now, for our labs purposes that you're doing in your electronics class, using the breadboards, LEDs, and resistors, the for that purpose, the resistance of the air is so huge that it becomes insignificant. So we can treat it as infinite resistance. But in reality, the air does not have infinite resistance. It has a high resistance, which means if the voltage is high enough, the current can flow through that resistance, right? And it can jump across. So if there is too much voltage across the narrow gaps, the arc flash can happen. Failure of insulating materials. I'm pretty sure I don't have to explain that. This is self-explanatory here. Loose connections. Guys, see why I'm so strict with marking some of the, and I'm strict, and I'm trying to get you to create proper terminations. Now, we're terminating the duplex receptacles for the purpose of 110 volts systems in our class. But I'm trying to get you into a habit of making sure that the connections are nice and snug, they're solid, and there are no any loose connections, no wiggly room in the connections. It is not, we are not connecting Lego blocks, and if something doesn't work, it's just, oh darn, it didn't work. Even with the 110 volts on 110 or 120 volts that happens in our electrical system, residential, commercial here. If you connect enough load, if you load it enough, that can also start a fire. Right? So fire is not an arc flash, but then again, loose connections can cause sparking. If you have enough voltage and enough current, enough capabilities, then it can cause an arc flash. It's just a matter of how much energy can be released when there's a complete dead short between terminals. What's the ampacity? What's the current capability under dead short conditions? And that current and the voltage, remember, power is voltage times current when it comes to RMS values. Then the arc flash can happen more or less severely, right? All right, equipment failure, self-explanatory. And here's a big one. Workers assume that the electrical equipment is de-energized. Well, in this one here, you're going to be educated and repetitively trained on the arc flash and other safety measures. And from one company to another, the procedures may vary, but there are some things that call lockouts or tag outs. A lockout is a specific mechanical device that is being put on a disconnected equipment in such way that it has to be unlocked in order to be turned on. Right? So circuit breakers, for example, or closure panels. A common practice also is that, for example, when you go to work on certain device and it is far enough, or maybe around the corner from the main power supply, the electrical panel where the circuit breaker is that you're going to turn off, and you don't see it. So it's also a common procedure to have actually a human being standing there, sort of like an attendant, just standing there and making sure that there is no some sort of an idiot that is going to come over and say, oh wow, who turned this thing off, let's turn it on, bang, and then you go goodbye, right? So it's a common procedure to have an attendant at the electrical panel, making sure that nobody accidentally turns on because they think that it should be turned on. All right. Now here, I hope you had your lunch. This is not for children. All right. The consequences of our class: okay, electric shorts, shocks, severe burns, blindness, deafness, shrapnel wounds, long blast injuries, all right, and death. All right, okay, let's not have this thing here for too long. All right, arc flash blast effects. It's an explosion, all right, so you can have the sound. The arc blast at 2 feet, excuse me, can reach about 145 decibels. Let's see here. A jet engine at 200 feet. 200 feet is not that far, right? It's about 132 decibels. So you can compare these two, right? And the pain threshold, that the volume is so loud that it is actually causing you physical pain. The threshold is 130 decibels, right? So that's the sound. Heat, all right? Arc flash up to 20,000 degrees centigrade or Celsius, which translates into 35,000 degrees Fahrenheit. Just to compare, the temperature of sun is 5,600 degrees Celsius and 10,000, so see that? All right. All right, arc blast. Just get this thing here. I had some Zoom panel obstructing my view here. Arc flash blast effects, right? What can arc flash do? Remember the train, the picture of a train I showed you? The electricity can, on that one little, well, relatively small wire to the mast of the rest of the train, can move that train just like a feather, right? So there's a lot of energy going on there. So arc flash effects blast, it can throw a worker off a ladder. Now that will be a small arc flash. It can throw a worker into a nearby walls of equipment. It can throw you, again, if it can move a train like a feather, just imagine how much less do you weigh comparing to a huge train. Uh, there is no comparison, and you're just a speck of dust as far as the energy is concerned. So it can throw you against the walls or other equipment. Right? Now, what do we have here? 1,400 kilograms. Mm, just as a comparison, I think if you just get the 2-liter bottle of pop, it is about almost like 2 kilos. All right. So, so that's 2 kilograms. So 1 kilogram is 2.2 pounds. All right. So 14,000 kilograms per meter squared force, or 2,000 pounds per square foot of pressure on a body can cause. So basically, it's just if somebody just pushed into your chest, so there's a pressure and it's a sudden one, what can it do to you or to us? It can cause a concussion. It can collapse our lungs. If we can't breathe, we can't live. And it can cause a severe internal injuries. And this is a, trust me, this is a gentle way of putting that. Projectiles caused by by the blast travel at speeds greater than 1,600 kilometers per hour. It's just like a projectile or a bullet from a gun. And what happens if a bullet that comes out of a gun hits a human body? Well, it can cause a lot of damage. Well, this is just like a bullet. It could be screws, bolts, or nuts traveling at the same speed. They have the same mass or greater than a bullet, and they still travel at the same speed. Well, you use imagination. Use your imagination, right? Uh, Okay, now here we have some logos of some organizations, and there's the Canadian Standards Association, Canadian Electrical Code, Occupational Health and Safety Act, Institute of Electrical Workers, U.S. National Fire Protection Association. So here are a bunch of stickers or a bunch of logos. Basically, what it means that the arc flash is treated seriously, and things protective measures are being regulated, and it is official, more than official than not. All right, way more official than not. CSA, so CSA standard, the standard for workplace electrical safety in Canada, because we're in Canada, we're going to talk about things that are happening in Canada, right? So CSA, Canadian Standards Association. The rule Z462. Okay, I'm not going to test you on that. This is up to your code teachers. Electrical safety covers. Okay, electrical safety program, arc flash hazard analysis, flash protection boundaries. We're going to talk about those. Fault protection calculations. Sorry, fault current calculations, and this has something to do that how much current can the whatever at the point of the arc flash can be provided under a dead short conditions. Um, um, arc fault clearing times, incident energy exposure, and required personal protective equipment. So we're going to talk about the PPE, and we're going to talk about the boundaries today, right? Just to give you some ideas here. Now, there's the bill C-45 is a federal legislation that amends the Canadian Criminal Code. Oh, look at that. Things are getting serious. I told you things are official, right? Now, if you have the rights on working on explosives and handling explosives, thinking that can go boom, and if you have the official rights to work on that, well, if you are working, if you have the rights to work on electrical systems that can cause explosions, just like a bomb would, then, well, things are serious. And if there's any sort of negligence by the people who are working on that, then it would fall under the criminal code. All right. So Bill C-45 became law on March 31st, 2004, and is now the new section, blah, 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 criminal code, which reads, everyone who undertakes or has the authority to direct how another person does work or performs a task is under the legal duty to take reasonable steps to prevent bodily harm to a person or any other person arising from that work or task. Okay, the bill established new legal duties for workplace health and safety and it poses serious penalties for violations that result in injuries or death. Right? It also establishes rules for attributing criminal liability to organizations, including corporations, for the acts of their representatives, and also creates a legal duty for persons directing work to take reasonable steps to ensure the safety of all right. So things are serious, things are official, things are legal, and things are extremely serious because that's when a criminal code is involved, right? Now, Canadian Electrical Code, CEC Rule 2306, electrical equipment such as switchboards, panel boards, industrial control panels, meter sockets, enclosures, and motor control centers that are installed in other than dwelling units. Right? Dwelling units are apartments, places that people live. Okay, dwelling is living. So an apartment or a house would be a dwelling unit. So anything that any of those equipment that installed in other than dwelling units, right? So other than places that people normally live, so it would be commercial or industrial environment, are likely to require examination, adjustment, service, or maintenance while energized, shall be then anything that requires that kind of maintenance while energy shall be filed, should be field marked to warn persons of potential electric. So anything, basically what this one says, if there's any of that equipment that requires maintenance while being energized or otherwise working, that can cause an arc flash, it should be labeled. Right, that's basically the marking referred to as sub rule, blah blah blah. So these are the rules that we're having here. Okay, so basically that's what it means here. Okay, thank you. So anything that any equipment that is in industrial use um, should be labeled. Quite often you're going to walk down the street and you're going to see some of those green transformer units, and you're going to see some stickers warning you of electrical hazard, right? And then you can see somebody walking their dog and the dog is going to pee on that. All right, so well, okay, so let's take a look at some of the hazard risk category levels. All right, CSA Z462 has identified 4 hazardous risk category levels, which are numbered by severity. So there are 4 categories. So hazard risk category is the level or arc flash protection clothing you must wear to protect against a minimum level of incident energy measured in calories per centimeter squared. So the energy that we are measuring that can be released, the unit of that is a calorie per centimeter squared. All right. Meaning, what's the meaning? The electrical equipment, depending upon the energy delivering capability under fault conditions, can cause explosion or arc fault of a certain level, measured in calories per centimeter squared. That explosion can deliver a certain amount of heat to a certain distance. So we're talking about heat now. Right? Each level 1 to 4 is rated at certain amount of flame resistance measured in calories. So we're talking about heat delivered by the arc flash, and we're talking about protective clothing that is rated at the heat delivered. Okay. So how much heat can the arc flash deliver, and how much heat can the protective clothing hold? And hopefully those two are going to be not much. Maybe the P.P.E is going to win the situation here. All right. All right, come on. All right, what's a calorie? A calorie is an amount of heat needed to rise temperature of a 1 gram of water by 1 degree Celsius. So if you have 1 gram of water and you make it make the temperature make it warmer by 1 degree Celsius, you delivered 1 calorie. Thermal energy is measured in calories per centimeter squared. All right, just to imagine, just so we can have some sort of visual here. 1.2 calories per centimeter square. So if you're holding your finger in the blue part of the flame for 1 second, so you're going to get 1 calorie per centimeter squared. All right, personal protective PPE requirements. Hazard risk category, and this is going to be on some of that is going to be on the test. I'm telling you that already. Right? Hazard risk category, so 1, 2, 3, and 4. And the severity is as such. 4 is the most severe, and 1 is the least severe as far as the personal protective equipment. So, number 1, arc-related flame retardant shirt and flame retardant pants, or flame retardant coveralls, 1 layer. Required minimum arc rating PPE calories, so it's supposed to withstand 4 calories per centimeter squared. That's a lot, actually, because we're talking about that lighter here. If you're just holding the finger in the blue flame for 1 second, you got 1 calorie. That's per centimeter squared. A human chest has many squared centimeters, not just 1. So just add that energy. So it's 4 per centimeter squared. Now, hazard risk category 2, PPE. It's supposed to withstand 8, so double of that, 8 centimeters, 8 calories per centimeter squared. And we go arc rated flame retardant shirt and flame retardant pants, or front cover, 1 or 2 layers. So we're pretty much layering up. It's just like an onion, right? All right, so 3. Okay, look at that. There's a big jump. It's supposed to handle more heat. What do we need for that? Arc-rated flame retardant shirt and pants and coverall and arc flash suit selected so that the system arc rating meets the requirement minimum 2 or 3 layers. That should give you the protection against 25 calories per centimeter squared. This is just, we're talking about heat. Just keep in mind, if that thing throws you against the wall, the flame retardant pants are not going to help you. Right. So then here is the hazard risk category number 4. That's the most severe, and it's supposed to withstand 40 calories per centimeter squared. And here are the requirements that you can actually read here. All right. Now let's just look at this thing. Personal protective PPE requirements. Right. There's the PPE should limit the incident energy level of the arc flash to 1.2 calories per centimeter squared. Remember the 1.2? Yeah. Against the worker's chest. Look for a label that states 1506 approval, ASTM, ASTM says American Society for Testing Materials. Look for those labels. Arc rating of the garment. Well, personal protective arc rating of the garment. So the garment should be rated at arc rating. Okay, there you go. Whoever wrote that. All materials in the garment should be flame retardant rated. Okay, so here's the thing. That should be a topic. And then there's explanation. Arc materials in the garment should be flame retardant thread. Now, here's the thing. Not just the fabric, but everything that is on it that can catch fire. If the buttons can catch on fire, you are on fire and you're going to feel that burning on you. All right. So we just have to make sure that all the materials that are used to produce that clothing are flame retardant. Right? So that includes the thread, the buttons, insulation, zippers, and whatnot. Right? What is the meaning of ASTM standard? The group developed as a well, you can read that thing here. There's a bit of a history here, so I'm not going to test you on that. This is for your information, just so you're in the topic. Okay. Now, personal protective equipment here. Remember we talked about these here. Hazard risk category 1, 2, 3, and 4, and here's the description of the clothing. Well, that's what the clothing looks like, right? Hazard risk category 1, 2, 3, and 4. Right? Some of that might be on a test. Hint, hint, wink, wink, nudge, nudge. All right. All right. Tasks with potential arc flash for potential for arc flash. Right. So what would be the works that we would have? Okay, operating a switch or a circuit breaker. That there's a potential of arc flash. Right? Inserting or removing a circuit breaker. That can have that can produce a arc flash. Opening an enclosure door. So here's the doors. Hinged, bolted covers. I just got some pictures. So here's a hinged cover. Here's a bolted cover. Right here, and here's a hinged and bolted cover. Right. So opening an enclosure door, removing a cover, hinge or bolted, that can cause an arc flash. And testing for voltage. Remember when we talked about the multimeters, and there would be certain categories for multimeters. These are not just for fun. You're not supposed to use the little tiny small multimeter that you buy in a local hardware store on some of the serious equipment, because it might not handle the energy that is being provided to it, and it can just blow up in your hands, and it can cause more problems, because once the explosion is started, it can trigger other things, right? So testing for voltage well, can cause an arc flash. All right. Now let's talk about some boundaries. This is the last thing that we're going to talk about. I'm giving you two scenarios here. One from the 2015 Canadian Electrical Code, and then there's the current one, which is 2019. And I'm going to point out to some of the differences that are happening between these two. Now, what are boundaries? A boundary is boundaries talk about this as approach boundaries. If there is an equipment that is capable of producing an arc flash of certain power or certain energy, then things are being regulated in a way that who should be allowed to even come close to that equipment, and what kind of credentials do you need that would let you come closer or not as close to that equipment. Right? So it's almost like, remember we talked about the confined space. It is sort of like a confined space in a different way, but these are the arc flash boundaries. So these are from the 2015 boundary areas. Right? So here's arc flash protection. Nobody can come close. And here's exposed and energized electrical conductor or a circuit part. So this is the closest you can come, and this is the furthest you can come. All right, let's see. The gray area, because see, we have from 2015 we had the gray, green, yellow, or red boundary. Okay, so the gray flash protection boundary right here. Now, right off the bat, I'm going to tell you this, because some people might ask, all right, what are the distances here? Well, the distances may vary from one situation to another, depending on the severity of the energy delivered under a total short. Right? So the distances could be different from one situation to another. Right? So here's the flash protection, but at this distance, that's from the 2015. Right? At this distance, PPE must be worn to protect to protect second degree or greater burns if exposed to the arc flash. So this is the outmost boundary furthest away from the energy source. Unqualified person can approach unaccompanied, right? Unqualified person might only cross this boundary accompanied in a company by a qualified worker if they need to, right? Should an arc flash occur, the person exposed to the blast would be subjected to the heat generated by the flash, resulting in second degree burn, which is 1.2 calories per centimeter squared. All right, so here's the gray area, right? Now, limited approach arc flash boundaries. So here we're talking about the green, and again, this is from 2015, now replaced with 2019. Unqualified person may enter when continuously in company by a qualified worker, appropriate level of PPE, and trained for the task. So I guess two people here. You can approach that for whatever reason you need to. Right? Then we're talking about the yellow, restricted approach. Only a qualified worker can enter. Appropriate PPE, level PPE, properly trained for the task to be performed. This boundary is restricted to unqualified personnel. Exposed electrical energy conductor, 50 volts or more. Not that much, eh? All right. It requires approved work permit. All right, so then we can get official. You can't just walk in there because I'm qualified. There's gonna be documentation here for you to. There's gonna be a reason for you to go in there, and it should be documented. Requires an approved work permit with a written plan of task to be performed. There should be a reason why you are here. You can't just walk in there to take a look because you have nothing else to do. All right, so the written plan should include well-defined procedures to prevent exposures. So it's just like almost like a confined space procedure, right? Remember that one? All right, and here is the prohibited approach. That's the closest area to the arc flash boundary. This is basically you're standing at the energized live part, considered the same as making contact with the live part. Distance varies from direct contact to several feet, depending on the voltage and depending on the energy that can be delivered. All right, now, so that was the 2015 version. And I'm showing you that because sometimes you're going to hear people talking about that, and that some of that might be mentioned. And I just want you to have that knowledge that something like that existed just before 2019. Now we have 2022, so here, not that far, all right? Now, for the 2019 electrical code regulations, then we have, well, a little bit less of those boundaries, right? So 1, 2, 3, 4, you go 1, 2, 3, all right? So what do we have here? We have arc flash boundary, limited approach. Okay, so we have a limited approach, restricted boundary, and restricted space, right? Limited and restricted, okay? All right, so arc flash boundary here. The arc flash boundary or restricted approach boundary changes depending on the potential arc flash hazard. Remember, that's just how much energy can this thing deliver. The arc flash boundary is calculated to 1.2 calories per centimeter squared of the incident energy, right? That's the distance where a worker without PPE would receive second degree burn. So we're talking about the furthest boundary here. Sometimes this boundary is the furthest one from the exposed equipment. Other times the limited approach boundary is the furthest out. Yeah. Right. When arc flash boundary is the furthest away, it becomes the line no one shall pass. without training, PPE. If the limited approach boundary is further out, then that should be the it should be treated as the line no one should pass without PPE. So this is the furthest one, limited. No, that's the arc flash boundary. Right? It's called the arc flash boundary. No one can come close to that. Things are changed, a little bit tougher. All right. Then here's the limited approach boundary. Moving towards energized equipment, exposed equipment, you will find limited approach boundary. So if you come closer to that, within this boundary, it is still possible to be exposed to a shock hazard. Appropriate PPE should be worn by qualified workers in the limited space between the limited approach boundary and the restricted boundary. So here is that, here between here and here. All right. Well, that's the here, between here and here. Non-qualified someone who's not qualified workers should stay outside of this boundary unless wearing proper PPE and being escorted by a worker with specialized training. So we're talking about this area here. And here is the restricted boundary here. That's the last boundary. The area closest to the live exposed equipment is within the restricted boundary right here. In order to pass this boundary, you must be a qualified worker with the proper training and PPE. If you need to perform work on the energized equipment, you might also need a work permit and documentation. All right, so are you ready to go and walk towards the boundaries? By no means, no. All right, you're not ready to walk. I'm giving you heads up on the what is being used in industry and how things are being solved. So when you see electrical equipment of that looks like is kind of serious, and some of the circuit breakers are well, the size of your arm, then if you're standing too close to that, you can just reflect, uh-oh, I don't think I should be standing here. Remove yourself from there immediately, right? If you can take any lesson out of this one here. But I also want you to know that the boundaries exist. And they talk about how close you can come to a live energized equipment. And that has to do with the arc flash protection or eliminating your exposure to a potential arc flash. Okay, so this is the last class of this whole term. For those who haven't made it to the class and watching the recording, yeah, I'm going to tell you at the end. The assignment is extended, deadline is extended to Sunday midnight or 1 minute before midnight. So Sunday is December 4th, 2022. So you got a couple more days to do the assignment. It was just brought to my attention that you guys are overloaded with other assignments as well. So why not? I'm just going to give you a little bit more time to continue to finish the assignment here. All right, cool. It's been a blast, which is a funny thing to say when we're talking about arc flash here. I enjoyed working with you through the whole semester with every single one of you. And here's the thing, I'm going to see you next term during the winter term with something that's called a network cabling core, network cabling course, elect 1013, I believe that it was. And we are going to explore the world of the data infrastructure. And that's what I'm going to tell you right now. All right, cool. Thank you very much, guys, and have a wonderful, wonderful Christmas break. All right, thank you, guys. Okay, bye. I need to stop this thing here, right?